So in the previous video, we basically looked at the three properties or laws of logs that we also proved. So a product opens up into a sum, we said. A quotient or division opens up into a subtraction. And then if I have a little power outside, I can drop that power in front of the log. Those were the three properties or laws. Now we're going to go practice a bunch of them with actual numbers involved. So the first one says simplify, and we're going to go apply the properties to write it as a single log, maybe to see what we can do with them. So this is a subtraction of two things. I'm going to change that into a division inside one log. So that's going to be log base 2 of 60 over 15, because a division would open up into a subtraction, remember. So if it's a subtraction, I'm going to condense it back together into a division. That's going to be log base 2 of 60 divided by 15 is 4. And that's fairly straightforward. 2 to the what gives me 4. The exponent would have to be 2. So I couldn't do log base 2 of 60 in my head, because 2 to the what gives me 60. I don't know exactly. I would have to, get an approximation. And 2 to the what gives me 15. I don't know that either, because if it was a 16, yeah, that's a perfect, 2 to the 4th that gives me 16. But I don't know for 15. It would have to be, I guess, something smaller than 4. But by combining the two pieces into a quotient, I was able to exactly get the answer quickly. Let's look at part B. I have that little exponent waiting outside. If the bases were the same, like if this base and that base were the same, if they were both 2s or they were both 8s, then the 33 would just drop. That would be an inverse property. But since they're not, property 3 or law 3 tells us drop that 33 in the front. So there we go, 33 log base 2 of 8 is what I end up getting. And now I can do that in my head, no problem. 2 to the what gives me 8. We already know that's a 3. So now I have 33 times 3, which ends up giving me 99. Okay, let's go look at part C. Log base 5 of 1 over square root of 125. Well, this seems to be like a quotient inside the argument of a log. So maybe I should apply the second property and change the division into a subtraction. So I'm going to open that up into a log base 5 of 1 minus log base 5 of, I guess, square root of 125. So we'll start with that, because log base 5 of 1 is manageable. We can do that. That'll just pop out 0, because 5 to the what exponent gives me what? It would have to be 5 to the 0. Now here, I don't like that the radical is trapping the 125, so I'm going to write that as log base 5 of 125 to the 1/2. Because a radical is the same as a square root exponent. Now with that, and remember this minus is waiting outside too. With that, I can drop the half to the front with property 3 that we discussed. Well, actually, let me do that in the next step, because then it's going to be confusing and incorrect. So I have negative a half log base 5 of 125. And it looks like we're pretty much there, because 5 to the what gives me 125. Well, 5 to the 3rd will give me 125. That will spit out an exponent of 3, and I have negative a half waiting outside of it, so my final answer should be negative 3/2 for that original one that I started with. So I ended up applying 2 of the laws, the subtraction and division one, and then also the plopping down the exponent. Now let's see what we can do for this D, which has a lot of nested ln's going on. So why don't you pause the video, try it on your own for a little bit, and then come back for the answer. Now remember the property that we learned in the previous section, the two inverse properties. We said ln e to the something pops down to something, and e to the ln of something also pops down that something, because they were one of the inverse properties in the previous section. So we could apply that here, and inside the parentheses, if we work inside out, I basically have ln e of that business. So the ln and the e kind of undo each other, they make each other go away, and I have e to the 200 pop down. Then who's waiting outside? Another ln is waiting outside. So now I have the same thing occurring again. I have ln e raised to the 200, so the ln and the e undo each other, and what pops down is the 200 as my final answer. So that one was a little harder, but it really just involved the properties even from the last section, which was the inverse properties of just plopping down the things. If you have two inverses next to each other, you get back exactly to where you started. All right, let's go look at example 2, which applies the properties more and gives us more practice. We're supposed to use the properties or the laws to expand the expression. So to begin with, I have ln of a quotient. And I want to give you some maybe steps or suggestions. Whenever you're expanding, I always like taking care of the division first, and then the multiplication, and then the powers. Drop them down in the end. So if you just, most of the time, that's the best way to work with them. It of course depends on the problem, but I take care of my divisions, then I expand my multiplications and take care of powers last. So I do see a division here. I'm going to take care of that first. I have ln of r minus ln of 3r. That would be my first step. Remember, 3r is all one term. Now, ln of r, there's no divisions going on for the argument, no multiplication, no powers. So I'm sort of done with that one. There's nothing more I can do to expand. In the second term, I have ln of 3 times r. So I could expand that into ln of 3 plus ln of r, because a multiplication turns into an addition. Now be careful, there's a minus waiting outside of that that's going to affect things, and I still have the ln of r in front of it. So now I have ln of r minus ln of 3 minus another ln of r, and it looks like the ln of r's go away. Okay, I realize I've copied r when it should be a q. Let me fix this. So it's 3q, not 3r. So I have ln of 3 and ln of q, and I have ln of 3 and ln of q. All right, that looks better. So now I have ln of r. R is as simplified as it gets. Ln of 3, there's nothing I can do there. And ln of q, there's nothing I can do there. So this guy is fully expanded. I'm done with that one. Now part B, I would like to take care of any divisions if there were any, or multiplications, but I don't see any. I do see a cube root, and it's probably best to think of that cube root as power. So that we'll say is the same as log. And remember, the log has no base, so it automatically means it's a 10. So I have log of x squared plus 4 raised to the 1/3. Which means I should be able to plop down that exponent in the front. That's going to give me 1/3 log of x squared plus 4. Now when I get to here, when I look at the argument, there is no division, there is no multiplication, there is no power. I mean, there's a power with the x squared, but the x squared is trapped together with the plus 4 as one binomial. And remember, I told you guys one of the cautions. Let's go back up in the previous video. I said make sure if you have a plus or a minus inside the parentheses that you do not expand any further and make it into an addition. So only multiplication expands into addition. Addition inside an argument stays as is. There's nothing you can do there. So for this example, Once I get to x squared plus 4, I basically just stop and I'm done because I cannot expand that any further. Anytime you have binomials, trinomials, things added and subtracted inside the argument of the log, you can't touch them, just leave them as is. All right, let's go to part C, do that one together also. So I have division. I'm going to take care of the division first. That's going to be log base A of x squared minus log base A of yz cubed. So I took care of division. Now I can take care of multiplication next. I'll take care of this guy next and say, well, that's going to be log base A of y plus log base A of z cubed. And like before, don't forget, there's a minus waiting in front of everybody. And while I'm at it, I might as well bring that exponent in the front. So I have 2 log base A of x. And I'm pretty much there. I'm going to also bring this guy in the front in my next step. So I have 2 log base A of x minus log base A of y, and I'm going to bring down that 3 and distribute the minus in the same step. That's minus 3 log base A of z. Now my argument is just an x, the next argument is just a y, the last argument is just a z. There's no division, no multiplication, and no exponents involved, so I'm done. That's as expanded as it can get. Now let's have you guys try part D, pause the video, and then come back for the answer. All right, so I am going to take care of the division first. This is one whole. It's always good to have parentheses around the argument, so that's how it should have started off. Now that's going to open up into a log base 5 of y cubed minus log base 5 of that radical 2x. Now I can go ahead and drop the 3 in the front while I'm at it. That's going to be 3 log base 5 of y. And minus, let's think of that as log base 5 of 2x to the half. Because all of 2x is trapped under the half. And I can bring the half and drop it in the front. So 3 log base 5 of y minus a half log base 5 of 2x. And now I can take care of the multiplication. I know I gave you guys suggestions here, do the division, then the multiplication, then the power last. But in this case, since all of that was trapped under the radical, I just figured, let me take care of that power, get rid of it, and then I can deal with expanding the multiplication. You could have split that into a root 2 and root x and then done the multiplication first if you wanted to, but I just chose to do it this way. Now I know this guy expands into log base 5 of 2 plus log base 5 of x, and then I have the minus half in front of all of it and the 3 log base 5 of y, who's also waiting outside. So we're pretty much there. I have 3 log base 5 of y minus distribute the half. 1/2 log base 5 of 2 minus distribute the half log base 5 of x. And so now my arguments are a simple y, a simple 2. And I can't really do that in my head. 5 to the what gives me 2? I don't know. And I have my last argument, an x. So that is it. It's fully expanded. There's nothing more I can do with that one. All right, for the next examples, we're going to go ahead and work on them on the next video. So in this one, basically all we practiced was using the 3 properties that we had proved in the original video.